Hello everyone. So in this video, I will be discussing the heat part of the chip industry, specifically overcoming the heat challenge, and I'll discuss 3D packaging as well. So here on the main part of the screen, you can see on the top left, there's an image. It shows heat, how heat is measured in chips. On the bottom, there's some sort of like a graph with some labels highlighting some scale of a chip. And here, this right here on what is it on the right side of the image no, of the screen, I meant that's showing a 3D chip because it's in the third dimension. It's a 3D chip. So yeah, and that's connected to 3D packaging, which I will discuss later in the video. So first of all, I'll discuss the problem, and I'll discuss the industry, specifically chip industry, you know, and what events are going on, stuff like that. So first of all, I started off by discussing why overheating of chips is a problem. That's quite obvious. Overheating is a problem because um, it's a problem in the semiconductor industry because it causes chips to fail. That's the main reason. And the reason that's a problem is because when chips fail, they can't function effectively, and then the electronics is harder to it's harder for the electronics to work properly and all that. So it's a problem with the semiconductor industry in the semiconductor industry, but it has connections all over the place essentially. So recently within the industry, chip industry, finding the proper thermal solution has sort of shifted to become the most significant and researched topic within the industry. Some reasons for this are because you know overheating is very important, and it's also a hard thing to fix. It requires a lot of precision. You got to be very careful for this. Um, you know, it's not an easy thing to find a solution to. It's essentially, I like to call it the heat challenge because it really is a challenge. It's it's hard to find a one answer to it, and it's like a weighing boat. There are ups and downs. You gotta measure the pros and cons. And that's why it's called, as I mentioned here, a very complex process. Because sometimes you could do one thing to find a possible solution for the thermal possible thermal solution within chips, but then that might hinder the performance, or there are different side effects that you have to be aware of. So yes, as I discussed, there are a lot of considerations that go into which method to use. Yeah, there within the chip industry, there are different methods you could use for different like thermal solutions and stuff. So, like, for example, one like key consideration that goes into this is the packaging style. What style to package the chips in, and then there are many others beyond that. And they both have pros and cons, and you gotta consider them. That's what makes this thermal challenge really a difficult challenge. It's really big thing within the industry right now. It's highly researched. There's a lot of ongoing research on how to overcome it. Uh, so now I'll discuss some important points. So finding a thermal method to use is a limiting factor in the chip design process. What this means is that it requires a lot of planning, beforehand, um, a lot of being careful, precision to know, to prevent overheating, and then that's how you are able to find the thermal solution for a certain chip. And the chip industry performs thermal simulation tests So these are basically simulators that predict how a certain chip will behave under pressure and heat. And then now I'll discuss specifically how the thermal simulations work. So you see, because the chip industry is getting more complex and everything's getting more advanced to AI and all of that, the thermal part of the industry also changes. For example, these thermal simulation methods, they are starting to be used more with AI. So that's called AI integration. AI is being used more and more in the thermal simulation tests to predict whether just find the hot spots, predict whether a chip is gonna overheat soon, stuff like that. And other than that, other than AI integration, there's also something called actual validation steps. There's actual, more precise methods of validating that the chip does not overheat. As of late March, the chip industry has moved towards system technology co-optimization. So it's essentially this solution. It's simplified STCO. It's basically these mix of different techniques, to prevent heat. That's basically what it is. Uh, these this STCO method has proven to be, at least so far, it's a relatively new method, but at least so far it has proven to be highly effective um, and useful in the chip industry. The way it works is helps reduce the chip's maximum temperature. It's called the peak temperature of a chip. Helps reduce that temperature and thereby reducing the you know overall temperature of the chip. Uh, Specifically, you got some percentages here. Compared to traditional heating, traditional cooling methods, um, the STCO method has proven to be over 40% more effective, which is almost half, almost 50%. That's pretty good. And then STCO has, also lowers the peak temperature of chips from about 120 degrees Celsius to 71 degrees Celsius. So that's around almost 50 degrees Celsius. So that's a pretty big range. So now I'll discuss the conclusion, key takeaways from this, and where the chip industry is headed. So within the chip industry, it's becoming continuously more complex, and there's more advanced processors that are being used. And I even include some examples of this, such as hybrid bonding, multi-die packaging. There are other examples as well. And it is important to know that when these more advanced processors are used, you see, when there are too much processors that are being used, by that point, there's a higher probability that there might be an overheating in the chip, which is where the thermal management comes in. So, yeah, that's what I discussed here. And then the key challenge within the industry is to make thermal solutions more accurate in detecting hot spots. So that's a key challenge within the industry as of March 27th. You see, there's a push to make the AI that's used to detect hotspots in ships more accurate and less prone to error. Essentially, I even included here a bit of of an example here of how this could be used within the industry for engineers and stuff like that. So it says, for example, it is possible to use silicon blocks to take away excess heat, as a result reducing a GPU's peak temperature, given that the 3D stack is not on an overloaded task. So that is one way that there can be that overheating can be prevented within the chip, essentially. So what they're doing is they're using what is that, silicon blocks to take away the heat and stop the heat that way. So that is it for the video. I hope you enjoyed. Make sure to leave a like, subscribe. Make sure to leave in the comments what you think, and see you in the next video.